This is our video for lesson 1.7, and this is on rewriting equations and formulas. So we're going to start adding in a second variable into some of our equations, and then we'll be solving for a specific one of those two. For example, we'll look at this in just a second. Here's an equation. We've got an x term, we've got a y term, and it wants us to solve for x. That means our goal in this equation is going to be to get x all by itself, and then however y ends up in there, that's okay. In the past, these are the kind of the things that we've done. We've combined like terms when we need to, we've distributed, and then we use inverse operations to get that variable by itself, which in this case would be x. And this content seems to throw students off a little bit. The ideas are exactly the same. We're still going to continue to use these exact same steps. We're just going to have extra variables in there. So let's just look at this example over here to kind of get us started and kind of get us on the right track. So I'm trying to get x by itself. I'm still trying to do the same things. I got to get rid of this 2 because it's connected to the x, and I've got to get rid of this minus 2y. And if I can make both of those go away, I'll be left with just x, and that's my goal. We're going to go in the same order as well. If this was just a number over here, if this was just like minus 2, for example, we would just add 2 to both sides. Since there's a y, that's fine. We just have to take that along. So instead of adding 2, I'm going to add 2y. And whatever I do to one side of that equation, I have to do to the other side of the equation. So when I do this, I'm left with 2x equals 5 plus 2y. Right, these terms on the right can't be combined. Right, I've got a y term and then just a 5, so they just have to stay separate, and that's fine. When we divide now, right, we've got 2x, which remember means 2 times x. So to undo that, we're going to divide by 2, and x equals 5 plus 2y over 2. And we can leave our answer just like that, and that's fine. We need to recognize here that when we got this divided by 2, I have 2 different terms. What that really means is 5 divided by 2 plus 2y divided by 2. We could technically simplify this a little bit further. I could split that up, and I could say, okay, 5 divided by 2 plus, and then since 2y divided by 2 is just y, we could write it like this. Right? We could do the division on the second piece of that, but most of them are going to end up looking like this. So let's look at another example here. This time we're going to solve for y, so our goal is to get y by itself. I'm just going to rewrite the problem. And this is really similar to that last example. I'm going to get rid of this plus 4x first, and then I'll get rid of that 3. So we're just going to use inverse operations. Minus 4x from both sides. 3y equals 9 minus 4x. Divide both sides by 3. Y equals 9 minus 4x over 3. And again, we could, since this 9 is divisible by 3, we could split this up and we could do that little bit more division, but I'm fine with you leaving it just like this for now. One other thing we're going to see in here is sometimes we need to do the opposite of distribution if we have multiple variables. We'll see examples in a second, but first we just want to think about what is the opposite of distribution. So when we distribute, we have an example like this. And since this is multiplication, we have to multiply that 2 by both terms. And when we do that, we would get 6x plus 8. And we can go in the opposite direction here as well. That's what we mean by the opposite of distribution, and this has a word, it's called factoring. And when I'm factoring, here's kind of what I'm thinking. Notice when we distribute it, I've multiplied this 2 by both terms. So if I'm going in the other direction, what I'm thinking is, what's the biggest thing that I can divide both of these terms by? Right, so that biggest thing is 2, the biggest thing I can divide them by and still get a whole number. If I divide 6 by 2, I get 3x. If I divide 8 by 2, I get 4. So we're going to factor out that 2, that comes out front, and then whatever's left over stays inside the parentheses. So here's what I'm thinking when I do this is, what's the largest thing I can divide both terms by? So let's look at a couple other examples here. What if my example was 3x plus 12? So again, really similar to what we saw up above, but if I'm thinking to myself, what's the largest thing I can divide both of these terms by? Well, I can divide 3 by 3, and I can divide 12 by 3. So I'm factoring out a 3, what's left over? So 3x divided by 3 is just x. 12 divided by 3 is 4, so this becomes 3x plus 4. Okay. Same thing we had up above in this part, but now it would be multiplied through by 3. The examples we're going to see in this section are more likely to look like this, where we've got multiple variables and we're trying to get one of those by itself. So for example, if I was trying to solve this equation for z, it might be helpful to factor out that z. Remember, since this is all just multiplication, the biggest thing I can divide, the only thing I can divide out of both terms is that z. So if I were to do that, factor out the z, what's left over would be 4y minus 7. So again, the biggest idea is this right here. What can I divide both terms by? And whatever that thing is, I'm going to factor it out. I'm going to divide it out of both terms and then see whatever's left over. So moving on to our next example, that's exactly what we need to do here. So again, I'm just going to rewrite this. Plus 5xz. So this is that exact case where I need to do this. If I'm trying to get x by itself, I've got this term with an x in it and this term with an x in it, and I can't combine them because they're not like terms. This one also has a z. So this is a place where I would need to do that factoring. And if I factor out an x, I end up with 3 plus 5z. If at any point, if this is going a little too fast, I might just kind of pause and take a look at exactly what's happening and see if you can make sure you understand how am I getting from step 1 to step 2. Now, my goal is to get x by itself. We're only one step away. Right now I've got x times all this stuff in the parentheses. Remember, that's what that means. When we've got something up against the parentheses, that means multiplication. So I can just divide by everything that's in those parentheses. If I do it to one side of the equation, I have to do it to the other. And when we do that, we're going to be done. Okay? The whole reason we divide it here is because anything divided by itself is just 1. We would be left with just x on that right side. As I rewrite this, I'm just going to flip it because we normally write our solved variable on the left. Oops. It should be 3 plus 5z. And again, these look kind of weird when we end up doing this. I've got all kinds of variables and they're all over the place. But notice we're still just doing the exact same steps that we have always done. Nothing has changed in the process. The things that we're moving around just look a little bit different. Here's one where we need to do some of that factoring again. Okay. S equals 2LW plus L2LH plus 2WH. And this is an equation for surface area. This is something that we may use at some point, if not here, maybe in geometry. And our goal is to solve for L. So I've got an L in this term, and I've got an L in this term. And I can factor it out of just these two terms. Okay? There's a 2 in there. I could also factor out the 2. But I think it's going to be in our best interest, since we're just trying to get L by itself, to just factor out that L. So if I factor an L out of those two terms, right, so I'm just thinking about this piece right now, and then I'll add on the 2WH in just a second, I'll end up with 2W plus 2H plus 2WH. And so again, I'd forget about this for a second here, and remember I'm just trying to get this all by itself. So I've got two terms to get rid of. I'm going to have to subtract away this term, and then divide off this term, and I'll be there. So we want to do this one first, minus 2WH. And so we end up with S minus 2WH equals, try to clean this up and I'm going to run out of room here. Minus 2WH equals L times 2W plus 2H. And now since I've got multiplication, we're going to divide. So on the right, that's all going to go away. And our final answer, I'm just going to rewrite over here where I've got a little bit more room. L equals S minus 2WH all over 2W plus 2H. And that is about as bad as it's going to get. All right, moving on to our final example. This one might make a little bit more sense as far as why we would want to do such a thing. We're looking at two different temperatures. So Fahrenheit is F and Celsius is C. And sometimes it depends on what we're given, how we're going to go about converting that. So in this case, since I've got C equals, this would be the case where maybe I was given a value in Fahrenheit, and I would plug that value in here, and then I would convert it into degrees Celsius. What we want to do is we want to use this equation to solve for F, so that if I was given a temperature in Celsius, I can convert it to Fahrenheit. So again, I'm just going to rewrite so I can show my work a little bit more clearly. Since the F minus 32 is in parentheses, I'm going to have to get rid of that minus 32 last. And so I want to undo this first. This is being multiplied, right? So you could divide both sides by 5 over 9. Right, that would work because right now it's being multiplied there. What we generally like to do, and this is a way we've done this in the past, if instead we multiply, if we were to multiply by the reciprocal 9 over 5, that will also make that fraction go away really nicely. And just kind of on the sideboard, let me show you why. If I've got a fraction 5 over 9, and I multiply by that reciprocal, remember we multiply straight across. So this would be 45 over 45. Anything divided by itself is just 1. And so if I turn that into a 1, and it's being multiplied by something else, it becomes irrelevant. It basically goes away. So what are we at after we do this? Multiplying here is going to make that go away. So we'll have 9 over 5 times C equals F minus 32. Now just one step, add 32 to both sides, and we are done. So again, I'm just going to flip the order of this because we generally write our individual variable by itself on the left. So 9/5 times C plus 32. Okay, so now if I'm given a degree Celsius, I can multiply it by 9/5, add 32, and I will get degrees in Fahrenheit. So this final example is a way that we might use that. Okay, so if temperature on Mercury is 427 degrees Celsius, temperature on Venus is in degrees Fahrenheit, we would have to convert one of these in order to know which is hotter, which has the greatest surface temperature. So let's just use our new equation. Okay, so it gives us that Mercury is in Celsius. We'll convert that to Fahrenheit and compare it to Venus. So our equation is F equals 9/5 times C plus 32. And since this is our C value, we're just going to substitute that in there. 9/5 times 427 plus 32. And you should just be able to punch that into a calculator, and when you do, you should get 800.6 degrees Fahrenheit. Okay, so that tells me that Mercury is 800.6 degrees. Venus is 864. Which one of those is hotter? Venus is hotter. And once we've got those in the same units, we can just compare them directly.